Hi, and welcome to the Unit 2.2b Solution Chemistry video. This is part one of two parts. The second part you will watch during class when you do the virtual lab. There are videos linked to part one, so you make sure you watch those to complete your notes. All right, in this video we're going to learn about titrations, which are a method used to measure the concentration of an unknown, or to determine the concentration of an unknown. So let's say, for example, I wanted to know what the concentration of an HCl solution is. So I have this HCl solution, hydrochloric acid solution, and I don't know its concentration. One way I can figure that out is I could say to myself, well, how about I figure out how much of a 2.5 molar NaOH solution I need to neutralize 10 milliliter of the HCl. And what I would do is I would set up a lab experiment that looks like this, where I have a Buret, which is a laboratory device that allows you to deliver a volume of liquid or solution and to measure that using the Buret. So I can pour out the amount of solution I need, and then I can figure out from the Buret how much in terms of volume I delivered. Here in the Erlenmeyer flask, I have what's called my analyzer titrand, and that would be where I would put my HCl. So I'd measure out 10 milliliters or whatever the amount it is I said I measured out. Once I've measured out the 10 milliliters of HCl, I can add water here. It doesn't matter because the moles will not change. Even if I dilute it, the moles will not change. Okay, so now in the experiment, what I'm going to do is I'm going to add NaOH until I reach what's known as an endpoint, and that's where I would know that the neutralization reaction of HCl and NaOH has ended, and I can use that to figure out my concentration of the HCl. All right, so here are some terms you need to know. There's something called an equivalence point. That's a point where the base completely neutralizes the acid, and you'll see that more when we get into equilibrium. For the titration we're doing now, we're really going to focus on what's known as the endpoint, and that is where the indicator changes color. So, and you'll see that in the video, and that tells us where we need to stop adding the NaOH. You have the titrant or standard, that is the solution with a known concentration, and you have the titer or titrant or analyte, and that's the solution with the unknown concentration. You can ignore the notes on equivalence point, pKa, etc., because that information will come later in our equilibrium chapter. Okay, there are two types of titration experiments, normal titration and pH titration. We're going to focus on the normal titration experiment, and you saw that set up before. So what I'm going to have you guys do now is you're going to watch a video that's linked, and then you're going to fill out the steps on your note slide and label the diagram and answer the post video questions. All of these are linked in the slides. And in this video, you're going to see a normal titration. So what you want to be thinking about is, what does this person do to during the normal titration? Label the diagram so you know what the setup is like, and then answer some post video questions that will help you to reflect on the process. All right, so you're going to pause the video now and then click on the link to the additional video, and when you are ready, after you fill this out, press play again, and we'll continue. Okay, so you have just seen the video on titrations, and you should have filled out these notes. If you have any questions on anything here and not sure what the answer is, bring those questions to class. All right, let's now go over the Buret Basics, because the Buret is the most fundamental tool we use in the titration. First of all, if you look at this Buret, you'll notice that at the bottom, the volume reading is 50, and at the top, the volume reading is 0. And that may seem kind of strange to you, because typically we see sort of the reverse happening. So if you think about a graduated cylinder or whatever, the top of the graduated cylinder will be where the 50 mark is, and then the bottom would be where the 0 is. So a couple things about Burets. The volume reading increases as you go down, which again is opposite to a graduate cylinder. So we start with 0 and then we go to 50. Also, the reason why that happens is because what we're trying to do is we're not trying to measure out the volume of liquid that we add to the burette, but the volume of liquid that is released from the burette or added to our titrant. Okay. We also must make sure we estimate the correct number of decimal places, and that goes in hand with reading the burette properly. So what you're going to do is you are going to watch this video, which will show you how to read a burette. You're going to list tips and key takeaways from the reading burette video to help you as a guide. Sort of things you want to look for as like, how do you determine the volume in a burette? How do you estimate the correct number of decimal places? That sort of thing. All right. Pause this video now and then watch the link. When you press play again, we'll continue. Okay, so at this moment you should have these notes filled out. We're going to try our first CFU, which is what is the volume of the burette reading? And so we have this card here that sort of can help you out. Take careful notes of the values. This is 41, this is 42, etc. And make sure you estimate to the right number of decimal places. When you press play again, the answer will be revealed. All right, so your answer should be in the range of like 41.14 or 41. That should be 1.17. So let me go ahead and just make that correction. And how did we get that answer? This line here, this longer line, represents 41. This line here represents 41.5, and that line there represents 42. So we know that each of these marks would represent 0.1 milliliters. So this will be 41.1. And our meniscus, the bottom of our meniscus, is between the 41.1 and 41.2. And I would say it's about halfway between, but maybe you see a little less, maybe you see a little more. But at any rate, we're looking at the bottom of the meniscus, and we know it's between 41.1 and 41.2. And the key thing to remember is that remember the values or the volume readings increase as you're going down. Okay. Now that we have looked at the titration setup and how to read a burette, what we're going to do now is we're going to watch a video on normal titration calculations, and that will sort of help you and set you up for the lab that you're going to do. So you're going to perform the calculations using the data and also answer the any questions that are there. So here is the data table. You're going to complete the data table and the calculations. And the data is going to come from the video. So what I'm going to have you do is I'm going to have you press pause now, click on the video that is linked, and when you press play again, we will continue. Okay, so at this moment you should have this data table and the calculations filled out, and you got that information from the video. Now we're going to try a couple of CFUs. This is CFU 2. You're going to use the observation below to calculate the concentration of HCl. So here we have in our Erlenmeyer flask an unknown concentration, 25 milliliters of an unknown concentration of HCl. And here is our burette readings, our initial and final burette readings, and the concentration of sodium hydroxide that's in the burette is 0.79 molar. Use all of this information just like it was done in the video to calculate the concentration of HCl. Pause the video now, and when you press play again, the answer will be revealed. Okay, so let's take a look at our answers. First thing that's helpful is to write down the balanced chemical equation. HCl plus NaOH goes to form NaCl and H2O. Because we want to go from the molarity and volume of an NaOH solution to knowing the molarity of HCl solution, we're going to use the shortcut here, because we're going basically from molarity and volume to molarity, which is the M1V1 equals M2V2. In order to complete that shortcut, we need to know the volume of NaOH that we added. So let's go ahead and calculate that. I read this burette reading here for my initial at 9.64 milliliters, and for the final 24.15. And that gives me, when I subtract those two values, final minus initial, I get a volume of 14.51. All right, so where's that information going to go? It's going to go my M1V1 equals M2V2 equation. I set my substance 1 as NaOH and my substance 2 is HCl. I know the molarity of NaOH is 0.79. The volume of it, I got it in milliliters, 14.51 milliliters. So to convert it to liters, I divide it by 1,000. I get this value. The N1 is the moles in the coefficient in the balanced chemical equation. The coefficient in front of NaOH is 1, so N1 is 1. For substance 2, it's HCl. The molarity is what I'm trying to figure out. The concentration of HCl is what I'm figuring out. My volume 2 is 25 milliliters of HCl, and again, I converted that to liter by dividing it by 1,000. N2 is the coefficient in front of HCl in the balanced chemical equation. There's a 1 there, so that means N2 is 1. Once I have all the information, I go ahead and I plug it in and solve for M2, and I get the molarity of HCl to be 0.45 molar. Please make sure you add the units. I forgot to add the units there. All right, finally, we're going to try CFU2. So here are some questions, basically testing your understanding of the setup in the titration reactions. All right, so you can pause the video now. When you press play again, the answer will be revealed. All right, so here are the answers. We typically put inside the burette the solution that has a known concentration, and that's called our titrant. We know that we've reached the endpoint when the indicator changes color at the because the indicator changes color at the endpoint. And in the video that you saw, the indicator was phenolphthalein, which changes to pink at the neutral zone once you neutralize it. All right, so that's it for part 1. For part 2, you're going to watch that in class during your virtual lab. I hope you found this video helpful. Have a quality day.